Now, a special type of logarithm that we'll use is called the natural logarithm. This shows up a lot in advanced math. A natural log has a base e. So e, remember, is a number about 2.71828. Okay, and so when we have log base e, we write that as, it's called a natural logarithm because e is the natural number, we call it. And so that's commonly written as ln x, ln for natural log, but it's backwards. All right, log natural, I guess. All right, so this is so common, there's a button on your calculator for it. So if you look on your calculator, you'll have a button that says ln. If you punch that, you can get an idea what the natural log of 9 is. On the Desmos calculator, you need to go to functions, and you'll see this ln key on your graphing calculator. It should be right on the front of the screen there. You'll find your ln key, and we can type this as the natural log of 9. And it's about 2.19, all right? Actually 2.20 if we round that off. All right, so now we can check that. All right, so we can see, all right, what does that mean? Well, that means if we have e to the x, and you should have an e to the x key, and if we bring our answer back here, so answer on a TI calculator, you'll hit second and the answer key, all right, and you'll get 9. Okay, there it is. Or if you type e to the, you type it in there, you'll get close, 2.19722, but you really can't type the whole thing in. That's why you got to use the answer key if you want to get that exact. Notice if you just type that number in there, it's not exactly 9, because this number actually goes on a lot farther. Your calculator knows it, but it can only print so much on the screen. Okay, so well, does this make sense? Well, e is about 2.7, so it's about 3-ish, and 3 to the second power is 9, so yeah, e to the 2.2 is 9. That sounds about right. Okay. All right. What about the natural log of 5? Well, the natural log of 5 is 1.6. All right. So the natural log of 5 is about 1.61. Okay. Which makes sense because e is about 3. And so 3 to the second power would be 9. So this is a little smaller than 2 because this is smaller than 9. Okay. All right, and so on and so forth. Okay, so we can also take this, and if we see the natural log of 2, and we want to divide that by 5, make sure that this 5 doesn't accidentally end up in the, oops, I guess it's 3, not 5. Didn't read right here. But make sure that number doesn't end up inside the parentheses. So you make sure you close those parentheses. All right. So that's how we use natural logs often there. So now let's look at the graph of the natural log of x. Now keep in mind that the natural log, as we just learned, is log base e. And so if we graph this, you can graph it on your calculator. On your graphing calculator, there'll be an ln key on your calculator. Just go to the y equals and enter y equals the natural log of x. Now, on your TI-83 or 84, one problem is that it'll look like it stops. So it shows up a whole lot better on a computer here or on Desmos. And this is the graph we get. All right. Notice it still crosses at 1, 0 like all the other graphs we just did recently. And it'll cross at this point E, which is 2.718, comma 1. All right. So we saw that a simple log graph will always cross at 0, 1. And then we know when you put an E in here, 2.718, okay, so that'll be 1. So the natural log of E means log base E of E, which is 1. All right, so 2.718 is 1, so there it is right about there. And it's going to be a curve like that, and then it's going to curve down, and again we're going to have a vertical asymptote. Never really touches that x-axis or that y-axis. Okay, so for some transformations here, all right, here we want to look at the graph of these functions, which we have the first one right here, and we want to think about the domain and the range. Okay, so for the natural log of x, looks like this, the one we just graphed. The domain, the x values, is everything from 0 to infinity. You got to put positive numbers inside the log. You cannot take the log of a negative number. You can't take the log of 0 either. That does not give you an answer. All right, so the range, that is, goes from negative infinity to infinity because it goes down forever in the y values, and this y value will go up forever. All right. Now, what about what if we put a plus 5 on the inside? Well, we've seen that when we did this with exponentials, and we've done it with quadratics. When we put a plus 5, look what happens. Okay. When we add 5 in the parentheses before we perform the operation, it moves which direction? It moved left 5. All right, so this whole graph moved left 5. Okay, so now the asymptote, instead of being at the y-axis, the asymptote is at negative 5. X equals negative 5. Okay, so quick sketch of the graph here will look something like this. At negative 5, we'll have the asymptotes, and it'll go through 1 unit to the right of that, and have the same shape like that. So here, the domain, you can see from the graph, the domain is from negative 5 to infinity. But how do we find that algebraically? So the key is you cannot take the log of a non-positive number. Or we can say that you can only take the log of a positive number. So we can only take the log of a positive number, which means that this stuff on the inside, the x plus 5, must be positive. It must be greater than 0. And we can solve that inequality by subtracting 5. X is greater than negative 5. Not greater than or equal to, just greater than. Okay? And so that's what this domain is telling us here. Okay? The range is still from negative infinity to infinity. So it's going down forever and it's going up forever. Okay? Well, what happens when we add 5 after taking the log? All right, so let's go back to our graph. And you can try this on your graph or your calculator as well. Okay, if we take the log of x and then we add 5, what happened? Well, notice it moved. Whoops. Come on. There we go. All right. So the graph moved. Didn't move left or right. It moved up. Okay. See that point right there? Okay. That was the point that used to be right here. Okay. We used to have this graph down here. Okay. That's the graph of log of x. And so log of x plus 5, everything moved up 5. All right, so that's up 5. So our graph looks something like this. And it's going to go through this point 5, 1. Instead of, I'm sorry, I should say 1, 5 instead of 1, 0. Because everything moved up 5. All right, so quick summary of what we just found, that we didn't do a full investigation there, but if we have the log or y equals log base b of x plus h plus k, that h number is going to move it left to right. And remember, left to right is opposite. Right is if it's minus something. Left is if it's positive something. K is going to move the graph up or down. Okay, so it moves the graph up if it's positive or down if it's negative. And the last thing that can change its shape here that we're going to focus on, there's a few other tweaks, but we're going to focus on the B here. And the B tells us if it's increasing, if B is greater than 1, all right? So if B is like 2 or 3 or 4, we're going to be looking like this. But if it's decreasing, that's going to happen when B is between 0 and 1. All right, like a half or a third. So that base determines the shape. Okay? And that's the basic idea of graphing natural logs. And this is not just for natural logs. This is for any log base B. But they're going to follow that same kind of pattern.